Thank you. So today I'm going to talk about slightly different topic than that I have been doing for a few years previously, and this topic is a bit philosophical but very practical, and this is very useful especially for teachers and students of architecture, and also researchers in the field of architecture. So therefore I thought that to share some of my knowledge with you, because this will be very useful especially for teachers and students. So it's about spiral method of architectural design process. So when you look at architecture, you simply cannot see from your eyes. Architecture is something you can experience, and we can categorize or place the whole scenario of architecture in three perspectives: process, product, and performance. Creating architecture involves a process. It involves a design process, and at the end of the design process you produce a product of architecture, and then when you have the product, this is for people. And so when there is a product, after having the building or the architecture, it needs to be function. So then there will be a kind of a section called performance. So in architecture, the process is important, product is important, and its performance aspect is important. So I'm going to talk today mainly about process. So this design process is a critical approach, and some of the people who were involved with teaching architecture term this as a critical method. In fact, this came from the critical method was broadly founded in critical rationalism for sciences first. This concept was given by Karl Popper in 1959 and 1963 in his work of Philosophy of Science. Science, even mathematics and science has philosophical part. So then after that, this critical method was then applied as a model to the field of architecture by Michael Brown in 1992 and 2003. And Michael Brown was an external examiner to Moratuwa for several years. So he applied this design process into architecture. Then in this process, as Alex Wright claims in 2011 in his publication, this model is an evolutionary one and presented and summarized by an equation like P1 leads to TT1, it leads to EE1, and then again P1, TT2, P2, TT2. So it can repeat. P1, where the P1 is the problem. So you need to have a problem to start a design thinking. Problem means some kind of statement about the project. Then it can lead to some initial theories, tentative theories, and then you need to refine that in order to error any elimination. So this is a process first introduced by Michael Brown in 1992. And then in 2000, so in this one, the P is the problem. Alex Wright claims that this P as a problem exploration, and later it was termed as problem definition. The TT was the tentative theories, but later the theorists and researchers and practitioners introduced this as trial solutions. And then the last one, EE, is about the error elimination, but Later, Michael Wright in 2011 described this as design development. So in this process, you need to start with the problem definition, and then after analyzing the problem definition, you need to come to a trial solutions. But to justify these trial solutions, you need to have a lot of research and then design development, and then finally arrive at a final ideal design solution. So this was presented as a paper in 2011. However, the same or similar design process was introduced to Moratuwa in the late 1980s by our former teacher Vidurasri Nammoni. So I compared these two theories and I found that it was the same. So we are fortunate to have this former teacher, and most of the architects currently practicing in Sri Lanka and teaching in Sri Lanka are aware of this whole process. Then Alex Wright in 2011 developed this process into another interesting scenario. It's something like this. You can see a spiral here. There are two spirals, the red one and green. So X is the position statement of a project, or it can be an initial solution. So it needs to go through like this, starting from the outer cycle. You need to have this spiral, and when you work out along this spiral, you find D, A, B, C. D, the area of D is bigger than A, and A is bigger than C. So that means it's a kind of a representation about the significance of various concerns. So in this one, D is more significant than A. So when you create a solution, you need to consider several aspects of the design. For example, if you need to design a museum, you need to think about the purpose of the museum. There can be a philosophical bias for this whole scenario, but you cannot forget the location, the environment, climate, technology. So there are many issues. So you need to respond to these things, but you need to respond like a spiral. And in the center you find the ideal solution. So you start your solution from X, but you need to narrow it down to an ideal solution. For that, you need some kind of thinking. You need to accept some theories. You can develop theories. So this is the whole scenario of this spiral process of design thinking. There can be many spirals. There can be many spirals with different types of solutions. So the advantage of this having this many spirals that, say a museum project can have a diverse approaches. In one you can start from here, on the other you can start from another place, considering several aspects. So advantage of having this kind of spiral design thinking is that it can be diversified. So then you can expect a kind of different characteristics in your architecture. This model, which can embed a certain value system also. You have an initial idea, but that idea, when you have that idea and when you develop this idea into a final design solution with the consideration of several concerns, then it becomes very meaningful. Architecture is an exercise that leads to create meaningful buildings. So, and this graph shows how the original idea can be converted or developed into a meaningful final product, which can lead to some kind of creativity. So with the acceptance of knowledge and with the acceptance or with the response to different types of knowledge, the initial idea can be developed into a final idea with more meaningful attributes. So this is the whole objective of this spiral design process, and this is the advantage of having this spiral process in the design. And so Michael Wright taught and presented 14 methods of developing these original ideas into a highly creative product. And he described all these concerns in 3 categories. Some of the ideas could be typological issues, like a fashion or craft designer does. And some of the methods could be determinism, like engineering design, or could be abstraction, like fine artist does. And these are the 14 ideas, like programmatic typology, where the scholarly understanding of building types and usages are important. Then, for example, elemental typology, generated by consideration of desired elements of the final proposition, particular architectural components. Then the archetypes, like complete architectural types, different types, historic types. Then displacement typology, where design solutions are generated by types from other fields like engineering or IT. Then stylistic typology, design solutions are generated by adaptation and adherence to the particular stylistic vocabulary. Phenomenological typology, design solutions are generated by focusing on provoking particular experiential responses. So like that, there are 14 considerations. 14 considerations you can adapt to create more meaningful architecture. And I found there's another type, which is loose fit. Loose fit is important in the context of sustainability, where buildings are designed for the general purpose. Buildings are not designed for a specific purpose. The function can be changed over the time. So we can include that also as another consideration. So that was about the process. And then how about the product? Product like this. One can discuss, have dialogues about the product for weeks and months. So you know what is scale, its proportions, the placing of the place, you know, its ambience that created by these buildings. So you need to think about the process. So the process, the product is also important. The process contributes meaningfully to produce products. Then the performance aspect of architecture. Performance aspect of architecture we can see from 3 different perspectives. One is about deductive reasoning. This is the thinking pattern of any aspect. Deductive thinking, where you find many issues, and all these issues can be looked at from a perspective to narrow it down to a very specific thing. So this is called deductive reasoning. So when a building is there, we can look at the building's performance from this perspective, or the other way. You start with a specific point of the building, for example, a window design of a building, and then you can generalize its findings to a larger population of buildings. So these are the 2 main thinking patterns used by scientists and researchers. And there is another one in between. There is abductive reasoning, where the reasoning usually starts with an incomplete set of observations and proceeds to the likeliest possible explanation for the group of observations. So most of the architecture research falls into this category. one example on deductive reasoning is something like that. You can investigate a whole building population in a city, for example, by analyzing its different types of plan forms, its different types of elevation sections, and then come to a conclusion. Recently we found that most of the office buildings in Colombo are during the daytime are overheated. So that's a research based on deductive reasoning. On the other hand, you can just start with one simple building and find out the findings, and the findings could be generalized into a larger population. So that's about the inductive reasoning. So these are the main research thinking which can apply to architectural research. And if you want to know about the areas that contributes to that areas contribute to the performance of various types of buildings are like this: building microclimate, building form, whether it is plan or section, the envelope, and mechanical plans. These 5 areas perform with the climate, and then it contributes to different levels of performance. So it's something like this. The whole architectural design process involves research, and the entire thinking process is like that. You start with some vague ideas, and then you need to justify with research, and then come to an ideal solution. So this is the whole exercise of, this is how architects design. This is how teachers do their tutoring for students. This is how the students are trained. So this is I have just one slide. So this is the summative perspective or the illustration of the whole thinking of architectural design. I have the last slide. Last slide is about, it's not about advertising architecture, but it's something about architecture. Recently, the Harvard University in 2019 conducted a survey based on questionnaire survey, and presented 55 highest paying courses with bachelor's degree, being among the most difficult university degree programs are architecture. So with respect to all the other professions, so this is the difficulty that architecture teachers, students have, because it's highly philosophical from one side, and on the other side it's highly scientific. So we need to resolve this matter. You need more time to learn architecture and practice architecture. Thank you very much.